In this video, I would like to discuss end of chapter question 1 from chapter 22 of the book Chemistry Cubed. I will just read out the question. State Huckel's rule and use it to predict which of the components 1 to 3 are aromatic. So you see component 1, 2, and 3 here on the screen. And yeah, so we first need to state Huckel's rule. So Huckel's rule actually helps us to decide if a component is aromatic. And the conditions that a component is aromatic is actually that a component needs to be cyclic, it needs to be non-planar, and needs to have 4n plus 2 pi orbitals. Pi electrons, and of course with that also p orbitals. And and also the double bonds need to be conjugated. So actually these are the 4 states of or statements of Huckel's rule. First cyclic, second planar, third the 4n plus 2 pi electrons, and fourth the conjugation of the whole pi system. And we can apply this rule to the molecules on screen. So first we see this molecule here, so it looks like a cyclobutadiene. And we can see, okay, it's a cyclic molecule, 4 carbon atoms in the cycle, okay, nice. It looks also planar. And then we are having a look at the number of double bonds here, 1, 2. This is actually corresponding to double bonds to 4 pi electrons, and this doesn't satisfy Huckel's rule because for Huckel we need either 6 or 2 pi electrons. In this case we have 4 pi electrons, so actually this component is not aromatic, but instead it's anti-aromatic. Anti-aromats have 4n pi electrons, and this is exactly the case for this cyclobutadiene. Second molecule is actually this cyclooctatetraene. So here we're having again a molecule that is cyclic. All the double bonds are conjugated, so always double bond, single bond, double bond, single bond, and so on and so forth. And we are having 1, 2, 3, 4 double bonds, and this corresponds to 8 pi electrons. So this also doesn't fulfill Huckel's rule. Because we either need, as I've said initially, 2, 6, 10, 14, and so on and so forth pi electrons. This one only has 8, so it doesn't fulfill Huckel's rule. It's instead also an anti-aromat. And what comes on top of that is also that it's not a planar molecule, but it's slightly bended, so the p orbitals are not overlapping in a constructive way. So this actually behaves more like 4 isolated double bonds. And the last molecule here in line is a charged molecule. It's a 5-membered ring. It's actually the cyclopentadiene. And we can see, it's cyclic. All the p orbitals are conjugated in a constructive way. And we can count the the p electrons, 1, 2, 3, 4 in the double bonds. And then we're having a negative charge here. And actually this orbital is filled also with 2 electrons. So let me also draw this lone pair here somehow. I think it should be somehow nicer to also add this here to make it clear that this molecule actually fulfills Huckel's rule because it has now 6 pi electrons, and this is exactly fulfilling the conditions of 4n plus 2 pi electrons. So actually this molecule is aromatic.